Hey everybody, welcome back to our mini series on parametric equations. We have a nice little equation here, and what we're going to do is today we're going to graph these and see a little bit more specifically how the restrictions on t and how this parameter affects our equations. So here, if we solve for sine t, we'll notice that on the first part, we would end up with an x plus 3 over 2 is equal to sine t. I just did that kind of fast. But in the second one, I would end up with y minus 1 over 2 equals sine t. And so since those are the same value, sine t, we're going to just write it as x minus 3 over 2 is equal to y minus 1 over 2. So canceling out our 2, since they're both in the denominator, we end up with the following. Y equals um, x, excuse me, I think I made a mistake right here, x plus 3, and then plus 1 more is plus 4. Okay, so I'm not going to do the um, algebra 1 part of that, but anyway, we end up with y equals x plus 4, which is a very simple line. So plot that on our coordinate plane, and we're simply going to dot this in because we know that the parameter will affect that a little bit. So here we are. Now, where does it go from here? You can't just slap that line in there and say you're done. Well, one of the things we notice is that sine t, even though t is not restricted, the sine of t is restricted to numbers between -1 and 1. So knowing that, let's figure out how that restricts our x and our y. Let's start with x. If we put in the number -1 as the answer for sine t right up in here, we would get that the lowest value of x is going to be, let's see, -1 times 2, which is -2 minus 3, or -5. So it looks like x is going to be greater than or equal to -5. And on the other end of that, if we put the highest number in, so we're going to just substitute in a -1 for sine t, and we're going to put in a 1 for sine t. If we put in a 1, we're going to get -1. Now let's see where those values are on our graph. It looks like -1, excuse me, -5 for x is going to be somewhere down here. Here's -5 for x on the graph. And -1 for x is going to be right up here. So I'm going to put a couple of dots right there. Now, obviously, this should also correspond to the y value. Now, if I did the same thing over here, putting in a -1 for the sine t and a 1 for the sine t, then you'll notice that we get the same thing. The y value comes out to be from -1, so I'll just write it over here. Y is going to be greater than or equal to -1. This is if I put in a -1 for sine t, I'd end up with -1. And if I put in a +1, I'd get 3, which is perfect because that's exactly where this is located. Now, unfortunately, we don't have an a and a b value. This is -1, 3, and this is -5, -1. We don't have a place to put our arrows or anything, so what I'm going to do is I'm going to illustrate this by putting arrows in both directions. So that tells us that the graph goes back and forth between those 2 points on this segment. Very interesting take on a line. Let's move on to the next example. This one has a sine and a cosine in it, and this one has a little fancy math trick that we can work on. And notice, of course, that our t is restricted from 0 to pi. Once again, I'm sorry, let me go back one moment. I didn't put these properly in domain and range form, but you would want to put those two items right there in domain and range form in set notation. Let's move on again. Okay, so in this case, if we were to solve for cosine t, we would end up with x minus 2 over 4 equals cosine t. If I square that, and you'll see in a moment why I want to square that, it goes back to the last video, we end up with x minus 2 squared over 16 is equal to cosine squared t. And on the other hand, here we're going through the y values now. We get a y plus 1 over 3 is equal to sine t. And then we'd end up with y plus 1 quantity squared over 9 equals sine squared t. And rather than try to convert one to the other, we can see that sine squared t plus cosine squared t is equal to 1. So therefore, this item here plus this item here must equal 1 when added. So I'd write x minus 2 squared over 16 plus y plus 1 squared over 9 equals 1. And we have a nice looking ellipse centered at 2, -1. Now, of course, in this case, we saw this in the last video. T is going from 0 to pi. So I would want to see what happens with this as far as our x's and our y's. So in this problem, if I go from 0, I would start with maybe the x's. If x is equal to, um, let me just rewrite this. If we're going to put a 0 in for this cosine here, so t is 0, that's going to equal 1. So x minus 2 over 4 would equal, for our 0 end, if t is 0, cosine of 0 is 1, so we put a 1 right there. And therefore x is 6. So that would be I guess, the starting point for x. And then if we put a pi in for t, then we end up with a cosine of t being -1. So x minus 2 over 4 equals -1, and x is equal to -2. So I have these two numbers. So it looks like x is going from 6 to -2. Of course, we haven't really talked about the stuff in between there, but for now, let's just keep it at that. In the y values, we see the same thing is occurring there. Unfortunately, at 0 and pi, t is 0. Excuse me, the sign of t is 0 at both places, so y is going from -1 to -1. So I'll just put that over here. Y goes to -1, and then y goes to -1 again. So it's both values are the same. All right, so just leave that for now. Well, what is this graph? This graph looks like, if we work this out, move this over a little bit, looks like it's at 2, -1, and it is an ellipse going left and right 4 units. So I'm going to put our vertices over here, left and right 4, up and down 3. So that's close enough. We don't have to be perfect in this stuff. Sorry, let me back that up. We're gonna of course dot this in, and we are suspecting then that the graph goes from x equals 6 right here all the way to -2. And so we're going to put our dot here. And of course, the real question is, what is happening? Is it going on the top route, like the northern route like this, or is it going on the bottom route? And we saw this in an earlier example. This one is going in the top route. All we'd have to do is put in the pi over 2 value to see that this ordered pair is proper. All right, I'm going to stop here for that problem because that's good enough from what we did the other day in the other video. So hopefully that gives you a good idea of how to do that. Don't forget to restrict your domain and range for x and y in this equation. Let's move on to the next problem. And this one is a little bit interesting just because of its unusual nature. Notice that it's got a radical t there, and if we rewrite this as x minus 2 is equal to root t, and we square both sides, we get x minus 2 quantity squared equals t. So I'm going to substitute that away momentarily. Let's do the second half. That's going to be y plus 2 quantity squared equals t. And so therefore, x minus 2 quantity squared is equal to y plus 2 quantity squared. And we end up with this very funky looking equation. If we were to take the square root of both sides, we get x minus 2 is equal to y plus 2. But don't forget, we've got a plus or minus situation here. So I only put a plus minus in front of the y because in that case, there's a repeat. So if you can try it yourself, put plus minus in front of both of them. But you'll see you only get 2 equations out of it. The first equation we're going to get is x minus 2 is equal to y plus 2. And the second equation we're going to get, I'll just set it over here, is x minus 2 is equal to -y minus 2. Now these two equations look very similar, and they are very similar, but they're not the same. This one is going to be y equals x minus 4, if I rewrite that in slope-intercept form. And this one is going to turn into y equals -x. And I believe that's it. So just y equals -x. So let me draw those two in there. I'm going to draw y equals -x, the easy one here. Okay, there it is there. And I'm going to draw y equals x minus 4. And it looks to me, and if I just go 1, 2, 3, 4, it's going to come up this way. Okay, and it looks like they both intersect right here at -2, -2, something like that. 2 over at 2, -2. There it is. All right, so what's the issue here? The issue is that we don't have two lines. The issue is that t is restricting things. So we end up with t being, of course, t has to be greater than or equal to 0. And so when we come back down to here, we're going to notice that something's going on. It doesn't look like we're going to want to accept this negative value. So the next thing I'm going to do is we're going to take this problem and put it on the graphing calculator to see what it looks like, just so that we can get some practice at that. So I brought up our graphing calculator here. In order to find that in our functions, notice we normally use this function here, the function symbolic view. But in this case, we're going to go down to the bottom where it says parametric right here. Just click on that, and you'll get a slightly different look. Second thing we're going to do is we're going to type in our values just as you see them here. So the x1t is going to be the square root of, and you still use the variable key, which is located just below the wheel here. And we're going to put that in there, square root of t, and then that's going to be plus 2. And just press enter. And then that'll go down to the next one where we'll do the square root of t, and then a minus 2. Don't forget you have to hit that little arrow key to get out of there. Minus 2. You don't want to put it all under the radical. And I'm going to enter that. Now before we could graph this, but before we do that, let's press shift and then plot up here and get the setup for the plot. Notice it shows that the t range is from 0 to 12 in the top here. We're going to want to change this 0 to 12 because the t range goes much further than just 12. Now let's just assume that we forgot about that. Let's delete this and let's type in something like let's type in like 10 just to show what would happen. If we were to plot this graph, look at what happens to the graph when we plot it there. It looks like it's a very small segment. But if we go back to that, set it up properly, and put in the right number, maybe like 1,000 or something like that, and then enter this, now when we plot it, we see that it's a ray. So this is a little bit more appropriate for us. And if we just trace along here, we'll see what happens with our t values as we move along. Sorry, I think I just messed something up there. Oh yeah, I'm all the way to 1,000 now. There we go. Well, you can kind of trace along as you go, and you can see what's going on with this ray. So does that conform to what we have in the problem itself? It does, but we see then that this is all we're looking for right here. We're looking for the positive side. So let's take a look at how that occurs. First of all, this was the equation y equals x minus 4. And the reason for that is that we should not be taking the negative side of this because of the fact that we have a principal square root to begin with. So that's the first aspect of the problem. The second aspect of the problem is that t is starting at 0, so t has to be greater than or equal to 0, and so that is our starting point there. Again, this restricts our domain and range, and so we do need to make sure that in our domain and range for x and y, we write it properly. I would write it this way, the domain, and we're writing domains and ranges in terms of x. X is greater than or equal to 2, and for the range, y is such that y is greater than or equal to negative 2. And that is how we would denote that after the impact of the t value. Hope this helps get you started on the rest of your assignments and also a chance to use that graphing calculator to check your work.